Gotchas for USB measurement. USB provides test engineers with an inexpensive, easy-to-use, high-speed bus integration standard for computers-based measurement systems. The standard, however, does not mandate signal circuit isolation. This leaves those who use USB for test and measurement applications open to a number of gotchas. To avoid problems, engineers need to understand isolation methods. Engineers considering using USB to integrate computer-based measurement system needs to understand isolation issues and how to deal with them before choosing their measurement hardware. They need to understand isolation issues so they can understand how external ground connections interact with not only the computer hardware but analog signal integrity as well. Isolation protects your PC from damage and preserves the integrity of the data by physically separating electrical connections between circuits, thereby eliminating potentially harmful voltage or current from flowing through your system. As Figure 1 shows, a data acquisition module, whether based on USB or not, consists of two sections: a measurement section containing the analog front end and digitizing electronics, and a data communication section that transfers those signals to the host computer in a non-isolated system. The measurement and data communication sections are both referenced to the same ground potential. The computer's chassis is ground. Data acquisition module architecture. Figure 1. Data acquisition modules. Whether built for PCI, USB, or any other bus standard, have a communications section and a measurement section. Designers of isolated measurement systems go to great lengths to ensure that there is no direct current path between the measurement and data communications sections. The USB standard does not mandate isolation. To do so would drive up costs unnecessarily. There is nothing in the standard requiring, promoting, or even suggesting that peripherals connected to the computer via USB be isolated. The engineers who developed and now promote USB, however, know how important isolation can be for many potential applications, including computer-based instrumentation. In all of their seminars, technical writings, and other communications, they strongly recommend isolation for a non-human machine interface, HMI, peripherals. Potential gotchas. The USB signals are on the order of 800 millivolts differential, which makes them low voltage differential signals, LVDS. As such, they are subject to interference from various external sources. These sources don't cause problems for highly shielded HMI applications, but they can trip up measurement systems that necessarily must electrically touch units under test, WTSs, in the uncontrolled outside world. A mouse or keyboard is isolated by the plastic case. There are 5 general classes of interfering phenomena that isolation helps shield your measurements from electrostatic discharge, ESD. Is any discharge from a static source into your measuring equipment. Typically what happens is the application locks up and you have to close it down and restart it. If you have a gross failure, you can blue screen your system or worse, damage your hardware. International product standards such as SCE ratings mandate ESD tolerance up to 4,000 volts for products with exposed metal and air discharge of 8,000 volts for shrouded or plastic devices. Ground ambiguity results from signals in different circuits being referenced to different grounds. Even a data acquisition card has separate analog grounds, digital grounds, chassis grounds for the shielded cables, and power ground when connecting your measurement system to the outside world. There is no guarantee that the WT wasn't miswired enough to apply 110 or 220 VAC into your analog ground or input-output signals. Even knowing there is a solid wire between 2 ground points is no guarantee. Current flowing through a power ground conductor can raise the voltage at the heart and enough to compromise your measurements or destroy your computer. Ground loops appear when there are multiple paths for signal and power supply occurrence to return to the power supply ground. Long cables act like antennas, magnetically picking up any low-frequency electric fields that happen to be wandering around the neighborhood, as Figure 2 shows. Fields generated by electric motors, transformers, and even building wiring carrying power to run the microwave oven in the break room generate significant fields that the ground loops can couple into your measurement system. Ground loop interference. Ground loop 60 Hz HUM radiated into ground loop. Non-isolated DAQ instrument, WD on the host computer. Figure 2 ground loops can appear when spatially separated pieces of equipment share a common ground. Ground and common mode noise. I'm going to pause this. Ground and common mode noise. I'm going to pause this.